Okay, wait a minute. Yes. Okay. Okay. So, excuse me, I want to ask you that you hear me? You see this?
Yes, we can hear you.
Okay. And mm, one thing. Just a moment. Still have one thing I would like to show you first, and then we will start the new chapter. Terrible. Okay. Mm-hmm. Mm. Okay. Ah. Hmm. Make a mistake. Terrible. I just make a file this morning and I put somewhere. No. It's here. Terrible. Okay. Sorry. That's let's see. That is I write down again the assignment 2. Just to here. The assignment is here. The chapter 2 is before, as I tell you before. Is that okay? But the last time I make some mistake. The deadline is April 4, not March 4. This one, and let me see today. Today we are March 30. No. Hey. Is it? Maybe I make a mistake. This is the last week. Is that right? Is that the day that we? The day is, so that means that, oh my God. Sorry. So it means that next week is the week we take the exam. Hello, you hear me? Excuse me.
Yes,
Yes,
teacher.
I can hear you.
And do you check that next week is the week we take the exam?
Yes. Yes.
Oh. So that's, I think that we still have one class next week, but that is terrible. Okay, so say. Next week we have SM already, so that's, I have to change a bit the plan. So I think that next week we will have the exercise time and presentation, but no, because it's changed from the here the page of the calendar to another page, so I make a mistake. So no problem. And the deadline is still here. Is that okay? But I mean that I want to bring it into the I will bring it into the this part still to the midterm test, but no, so we delay it to the final exam, no problem. But we need a presentation like this. The chapter 2, you make the assignment like this. You rewrite chapter 2. Is it okay? But I'm afraid that maybe you just copy and you don't understand. And so it's better to do like this. I need 5 volunteer students because our class is crowded, so I cannot divide it into a group and make presentation. So I need 5 volunteer students to form a group to make presentation at this spot. You understand? Each member of the group, if you do well your job, that in making presentation, the content of the chapter 2 or the assignment. That's the assignment. So you don't need to work with the assignment. You just make a slide and make presentation. 5 of you make one report, one slide file, presentation, and make presentation. The week after the week of the midterm test. Next week is the midterm test. That means you have no class. You understand? We don't have the class next week. But the week after next week is the presentation. So if you make well, so each student in the volunteer group will get 10 marks of bonus. Okay, and now the first 5 students, you raise up your hand, and I will choose 5. You come together, 5 students. Okay, Lâm Huệ Dung 1. Someone more?
Nguyễn Tuấn Anh number 2.
No, you raise up your hand. You click to raise up your hand. Minh Thư. Hello. Some more. I think Mr. Quang Khải or something like this. You get familiar with making presentation. Can you? Tuấn Anh, Thanh An.
Ủa cái này là sao thầy? Cái này là tình nguyện đúng không thầy?
Yes, and you get
Yeah.
10 marks of bonus if you do well. Okay, so I get 5 students already here. Nguyễn Phan Khánh Linh, Nguyễn Tuấn Anh, Trần Châu Thanh An, Nguyễn Thị Minh Thư, Lâm Huệ Dung. Okay, 5 students. Just a moment. You should take a photo and you know each other. Okay, you know each other. I write down Huệ Dung, Minh Thư, Thanh An, Tuấn Anh, and Khánh Linh.
Dạ thầy, em với Thạnh An là chung một nhóm á thầy. Dạ. Em Khánh Linh với Thạnh An chung một nhóm.
Khánh Linh, yes, just only one group. 5 of you remember? But Khánh Linh, you don't want to join it anymore? Hello? Nguyễn Tuấn Anh, Khánh Linh, you put down your hand. Hello?
Dạ.
You don't want to join in the group. So, okay, I need one more. So, Khánh Linh, withdraw. Another one. Khánh Linh, you want to say something? Okay, Lê Nguyễn Đăng Khoa. Okay, let's fix. Lê Nguyễn Đăng Khoa. So 5 of you know each other. Try to connect it to each other. Is that okay? I said again. Huệ Dung, Minh Thư, Thanh An, Tuấn Anh, and Đăng Khoa. Is that okay? You make a group. You need only make one report and make a slide and make presentation at class. You understand? Hello?
Yes, sir, I understand.
Yeah, okay, make the slide like me, and then you talk to people, and then you teach to people. This part is easy, I think so. It is very similar to what we studied before. Is that okay? But it's general. It's not only 1, 2, 3, but it's maybe M people, so a lot. Is that okay? Okay, that is the presentation. The volunteer group is here. And there are some exercise of the chapter 4. The chapter 4 is the exercise here is in the connect to this to the presentation. Is that okay? But the chapter 3 is, so let's say chapter 3, 2 and 1. 1 is nothing, just an introduction. But 1, 2, but 2, 3, the 2 chapters and the main content in the midterm test. Is that okay? And you have some exercise here, but the exercise of the game theory, I think, is very easy. It's the most important thing is the chapter 4. Take a look at the chapter 4. Chapter 5.
So exercise, do we need to submit the exercise, or we just do it at
No.
home?
Just work at home. No.
Okay.
Just work at home. Chapter 4. So chapter 4 not included in the final exam. In the midterm exam. In the midterm exam, you have a chapter 3. 2, 3. That's decision analysis. Then let me write down here. The midterm test. Decision analysis. That's chapter 2. And chapter 3, game theory. So the chapter 4 is more on game. It will be put to the final exam. Is that okay? So the midterm, just only 2 chapters like this. And this chapter, you see, actually this chapter, we don't have time. We don't have time to work with the exercise, but it's very easy. You can imagine. You can imagine, for example, here. So dominated strategy. You see what is it? It is very easy. And solving this by Minimax theorem, by the Minimax criterion. Is that okay? Let me delete all things and tell you. I think that the student in high school or even secondary school, if we tell them the way they do, they can do it. For example, Maximin, the player 1. Suppose that we're talking about the player 1 and the payoff is the payoff for the player 1. So Maximin means that we take the mean. We take the mean of the row. You see, 5 minus 2 minus 4. So the minimum is minus 4. 2, 0, 2. So the minimum is 0. Minus 3, minus 2, minus 6. The minimum is it. We take the minimum and we take the maximum of the minimum. So the maximum of the minimum here is this one. Is that okay? So that means that the best strategy for the player 1 should choose is 2. Is that okay? Strategy 2. And for the player 2, we have the minimax. So that means, first of all, you take the maximum. Maximum here, that means that the player 1 gain max. So that means that the player 2 lose maximum. Lose the most. Is that okay? So we find out the maximum max. And then from the max here, you choose the mean. Is that okay? That's all. So it means the minimum is 0. So that means that the player 2 choose the strategy 2. And the number is here. So that is the A22 here is the value of the game. You see? Exercise just like that. Find out, solve this game. Solve this game means find out the optimal strategy for the player 1 and player 2. Find out the value of the game. Is that okay? And the value of the game you look at here, that's 202. So here, 202. So let's go down and up. And here you see minus 2, 0, minus 2. Minus 2, minus 2, 0, minus 2. So it means that you go up and down, here down and up. And this bond is actually a stellar bond. Is that okay? So it's very easy. You have something here, the minimax, maximin strategy, and you have here unstable. You know what is the unstable game? Unstable game, like the last time I take Tuấn Anh maybe and Quang Khải, you play the game. Is that okay? Unstable means you think another one we choose it, and then you can change. Then it's unlimited. Is that okay? In that case, and this is stable. The value of the game is here, and you go through the line, you will have that is the minimum. So it's up and to the minimum and up, and to the column it is a minimum. So it's up and down and up. So very easy. And the next part of this chapter is strategy, mixed strategy, X1, X2, X3, something like this. I don't know what is the problem. Mixed strategy, and you have the minimax theorem. First of all, you take the mean. The mean, you have some line like this. Take the minimum of all lines, and then you have something like this. And when x1 from 0 to 1, for example, x1 from 0 to 1, and the line is this, so the maximum is a 10 at this one. Is that okay? And you have x1 star. From x1 star, you know x2 star. But this way we call the graphical solution method. And the graphical solution method here means that graphical solution method used only in the case one of the two players have only two strategy. If both have a 3-3, 3-4 or something, then we cannot use the graphical solution method. You know, that's the key point. And so the chapter 2 that some volunteer student will take the presentation there. We'll take the presentation there. The two kind of game, that's 2 multiplied by m. That means 2 by m game. That means the player 1 have 2 strategy, player 2 may have m. And you also have m multiplied by 2. So that means player 2 have a 2 strategy, but the player 1 may have m. Okay, m may be lost, 3, 4, 5 like this. And so this, and at the end, okay, that is an example of non-zero, and I put it to the final exam, so no problem. So the first chapter is about decision analysis. That is rather long, and this is nothing special. That is quite easy. It's many things there are just theory, and there is something about the making decision under risk, and no problem. Making decision under with experiment. You use some calculation using some just actually one theorem in one formula in probabilities Bayes theorem. That's all. Just very easy. Let me see. In the game theory, you have something more game with just a moment or something. We have some you have some what's before this one maybe. No, decision analysis. Decision with under risk, under uncertainty, or something like this. That's all. So it's short. So now today, that means that in the chapter 4 here, let me see. Chapter 4. So maybe, maybe like this. Because if we stop there, then the midterm test, the content of the midterm test is short, and the content for the final is long. So here, the midterm test until here, including the first two sections of this chapter. Non-zero sum game, just very short things, and cooperative game. Okay, cooperative game have the things. Cooperative game means you have some exercise like this. I need a little bit calculation. Okay, and the main point here, you see the main point here. There are cooperative game. The key points here is something like a saving. The saving amount. The first is face saving amount. The second is here. The nucleus value. So I forget this one. So I ask you to do the two things: the core and the Shapley. Here, the core and the Shapley value. So you consider here only thing core and the Shapley value. You calculate this. So you need a bit calculation. Okay, here, and that's all. Here, the calculation. The strategy of bargain. The first one come in the room, the second come in the room, third come in the room, and you have a perturbation of how you say, permutation of this. The third one come first, the second come like this, and you calculate and take the average. That's all. And with this chapter, we have two things here. This is the assignment 2, and it's also presentation. Okay. And this one is just you to study by yourself. You read, student read, and this for the final exam. Okay, and now we start a new chapter. This is chapter 5 here. Chapter 5 here. As I upload this chapter to the Blackboard already, and that is the first part. That is, let me see, I write down something here. Here. That is the part 1. Part 1. And you will see in this chapter we will study something, introduction to and prototype example of the this chapter, here, project management with the PE, RT, and CPM. Project management, that's the way how to manage a project, to control the project. And we have something here, part 1, it's here. It's scheduling a project and using the network to display a project. That's this thing. That's the first part. And the second part here have some calculation. Here have some calculation like the last part of the chapter decision analysis, something like this with uncertainty. Let me tell you, this is very. This chapter, the knowledge in this chapter is about, you know, it's used for project management. So it's very useful in your life. Okay, in the 20 years, more than 21, actually 21 years ago, when I first go to Ho Chi Minh City in the first year, I bought a piece of land and I built a house. This house now, and you know, I start building a house at I think it's about September or something like this, and the plan is very strictly. That means I make a project, you know. I build a house means a project to build a house. There is a project to build a house, and I need to finish it at the Tet holiday, you know. I need to finish it at the Tet holiday. Here, it is like this. It is like this. Tet is here, and that is the January 1st of Lunar New Year. Is that okay? And I make a plan. The project must be finished here. I make 20. I take the plan to finish it at 20 of December. December of Lunar New Year, you know, December of Lunar New Year. So I have about 10 days here. 10 days here to move to the new house and to arrange things in the house. And after the Lunar New Year, the January 9, that is the day I go abroad. I go to Korea for 1 year. See? So I have to, anyway, I start in about, I don't know, it's about September or something like this. About September, start here. And the project must be finished within this time. Because I cannot, people don't like to make the house in 2 years. So that means I don't want it finished in the new year. But you know, after this one is very dangerous. This time is very dangerous because the workers or something, they move back to have a Tet holiday in their hometown or something like this. So nobody to work here in this time. So anyway, finish the project and the deadline is this. Yeah. And you know, at that time, at that time I have not yet teach decision making. No, not. I do not teach this topic, but I know about the way to manage the project management, to use a kind we call Gantt. We call Gantt scheme. Gantt scheme, that means it's also like something like this, that CPM, PERT here. And I apply this this method, and I to control the project, and then during the 3 years I check every time the project, and then you know that the deadline when it is finished at about 22. That means about 2 days late. 2 days late, and okay, of course, is acceptable. 2 days later, so I have about 8 days to move to the new house, move my wife, my son to here, and install everything before leaving. It's about 1 week after the Tet holiday. I just want to tell you the knowledge of this chapter is a very practical. You can use anything in your life, your thing of yourself, not necessarily in your work, not necessarily in final engineering. You can use it everywhere in your life. And the problem is something like this. Here, this method of manage project management, we call project management, have been used successfully in variety of projects, such as the construction of new plant, new factory, okay, construction, even new house, like I tell you, research development a new product, develop a new product. For example, NASA space exploration, building a ship, maintaining a nuclear reactor, install management information system or something. Many things in our life. Okay, and a bit about the history of this method. The PERT means the program evaluation and review techniques, and the father is Pong de Nemus, and CPM is a critical path method. This proposed independent by the two people. Okay, but the second was developed to serve the U.S. Navy to manage the project of research activity development, a new kind of missile. You know, that is developed for manage the project of developing a new missile. Another one is proposed in about 1996, 98. That's like this. Original versions of PERT and CPM were not the same. They are a bit different, but they had a great deal in common, a lot of things in common. And now then when they develop and then they mix them together, and then they call the method project scheduling PERT and CPM, or project management by CPM and PERT. So what are these? CPM and PERT are network-based method designed to assist in the planning, scheduling, control of projects. A project is a collection of interrelated activity, with each activity consuming time and source. The objective of CPM is to provide analytic means for scheduling the activity. You have a list, the plan, the research, the project means a list of the activity. Okay, it come together. This you have to, for example, to build a house, you have to make the base. The base take 2 weeks. Okay, and then you make the wall. Okay, make some concrete things here and build the wall and make the put the ceiling or something. Each of the activity, for example, making the wall take 1 week only, but the ceiling, if you make a concrete one, and you have to wait for about 3 weeks. 3 weeks for it become firm, and then you continue the next thing or something. So each activity like this takes some time. When you make the concrete of the first floor already, and then you build the wall of the second floor, and then the concrete there, and then it's time for the electricity. The expert in electricity come to to blend the wire inside the wall, and the expert to work with the water, that okay, supply water to the toilet, so something like this. So each of the part like this takes some time, okay? And the problem that you have the project, a lot of activity like this. For example, here you look at in this example, you will see something here. For example, this they make a plan to build the factory or something. You see, lay the foundation, put the rough wall, put the roof, install the exterior plumbing, install the interior plumbing, exterior siding, exterior painting, electrical work, the wall board, the flooring, interior painting, exterior fixture, something like this. Is that okay? So a lot of things, and each of the activities here, for example, it's funny. And each of the activity you call A, like A is excavate, and excavate here take 2 weeks. Lay the foundation, B lay the foundation, and the foundation take 4 weeks. But here they give you some immediate predecessor. So it means that if you want to make the B, is lay the foundation. You have to do A first. Without A, you cannot do B. And for example, C, put the rough wall. The C, put the rough wall, must be worked after B, after you lay out the foundation, and then you put the wall. Okay, so it has some order. For example, if you want to do the exterior painting, you want to do the exterior painting, here is H. You must finish E and G. E and G means G is exterior siding, E is exterior plumbing. Is that okay? But if you want to do G, you must finish D. D is here, put up the roof, for example. So anything is come mixed together. This one like this. If you want to start this one, you must finish this thing. And during some time you do this one, you can do another one. But some of the, for example, J, if you want to do J, you have to finish F and finish I first, for example. So if you have project like this, is that okay? And you can list, of course, for example, if you want to calculate, put up the wall board and the, how do you know that you have to finish it after E and F and I? How do you know that it take you 8 weeks? Not easy. It's not easy. Is that okay? If you need the calculation of the expert. Is that okay? Each of the activity, you need the group of experts to work and to calculate how many times, how much time for this. You understand? How much time for this? And the expert will tell you, you have to do this after you have something like this, ABC here. And after that, you have a table like this. And the problem is, for example, this week, if you sum up all the weeks here, and then you will see, if you sum up week like this, and it become 78, 79 weeks. But this must be finished in about the week. You know, the project must be finished in about 47 weeks. But the total week you do here, you calculate here, it is what is it? It is 79 weeks. So it is not easy. And in case, for example, in case you want to do the foundation here, and you dig out the soil and you put the concrete there, is that okay? But today you want to do this, and in the morning they dig out the soil, the land, and prepare things for putting the concrete. This afternoon that we put the concrete there. But sorry, this at this noon it rains. It rains heavily, and a lot of water there. You cannot do anything. Just okay, stop. Okay, come back home. Tomorrow come back. Tomorrow still have water. You have to pump out water and do something. So in case there are some uncertainty, some activity is delayed, they calculate for you is 1 week, but actually it will last for 10 days, not a week. And some other they estimate that the work this activity is 2 weeks, but actually it becomes 3 weeks. So how can we do in that case? And how can we make the project still come in time? You know, like a lot of things. You know, in the winter we make things here, a lot of things, a lot of rains or something like this, and it take some activity is delayed, and based on the way to control the project here, I have everything. I have to push up so that it must be ended exactly at the time. Of course, after all, it's 2 days late, but no problem. That is okay. You still have time enough for me to. That is the error is 2 days, working in 3 months or 4 months or something like this, and just 2 days or 3 days late. That is acceptable. Okay, but we need the way to control it, to make the project end at acceptable. And in some case, the delay things can be unacceptable. You know, for example, now at the moment, because of the COVID, because of the war in Ukraine or something like this, every material for building house goes up, and you know that at the IU, our large building of about 20 storage there in IU, you see, the company who make this, who construct this, they give up. They break the project, and they really to pay money for punishment, because now they cannot follow the project. They cannot follow the project with the money they bargained before, because now everything goes up double. Okay, so you see, with the importance of making the project in time. And in some case, you will see that in our example here, there is very close to the real thing. If you make it in 47 weeks, that is okay. If you make it 3 weeks before, that means about 44 weeks, then you get some bonus. Then they will give you the bonus, $300,000 or something like this. But if you late 2 or 3 weeks, you have to pay large amount of penalty, $500,000 or something else. See, and so really important. And in this, there are 2 things. The second part I meant here. The second part means we finish in time. We make a project. We control the project in time. But in case I see that everything may be okay, then I have to calculate two things. I have to see $300,000 for bonus. That's good. Is that okay? So I think of reducing. If I can reduce 3 weeks or something like this to get the bonus money, but you know, if you reduce the time, you have to pay more money. For example, I think we plan this is to do it during the war around it. For example, 1 week. But if you want to reduce it 2 days, 3 days, you have to rent more. You have to rent more workers or something like this. So you have to pay a little bit more money. And in some case, for example, the floor, making the floor here with the concrete, normally it is about 4 weeks to be in the firm stable so that you can build more. But if now you want to reduce it 2 weeks, 3 weeks, that means reduce 1 week, you have to pay some more spices there. And the spices and change the new method or something like this, it will take money. So the second part of the chapter give you the way to calculate. Is it worth for us? For example, we try to reduce 2 weeks to get $300,000, but actually we have to pay about 280,000. We have to pay this to reduce 2 weeks in order to get 300. So that means that just only 220,000. Not worth. Okay, not worth and dangerous. So the second part of this chapter is calculating for that. Okay. So we come back to the horse story. That is CPM. What is it? What does it use? We use it. What is it? CPM and PERT method. It is the network-based method designed to assist in the planning, in the scaling, the control of a project. So what is a project? A project, here is a project. A project is a collection of interrelated activities, with each activity consuming some time and resources. Okay, time and resources. So the objective of the CPM and PERT is to provide an analytic means for scheduling the activity, because the project is a list of activity 1, 2, 3, 4, 5, A, B, C, D, F, like this, and with the relation together, and each of the activities have two factors, time and resource. Consume. It will consume time and consume resources. Okay. So what's more, the two techniques, combine them together in one thing, and we call CPM, PERT, CPM. Here, this see how it's used. It can use to construct a new plant, new factory, research and develop a new kind of product, like they have the plan, the project to build a new drugs, new medication or something like this. And NASA, space exploration, building a ship, maintaining a nuclear reactor, ISO management information system. Okay, many things they can use in many things. And as I tell you, even that things are very important thing, but even they can use in many small things in our life. Okay, you have a project like me, like many lecturer in the Department of Mathematics. We work with the we are a researcher, we are a lecturer at the university. We have some project to do research with the VNU, that's Vietnam National University of Ho Chi Minh City. We have project them, and we make the project of research in 2 years or something like this, and they pay us some money, but we have to finish in time. If you are late, you have to pay punishment. Okay. So we take we study things via an example. The example is about the Reliable Construction Company project. The company is a Reliable Construction Company. Okay, and the project of this. Let we here like this. The Reliable Construction Company has just made the winning bid of $5.4 million. You know, $5.4 million, the last amount. Can you imagine $5.4 million means how much Vietnamese? 1 million is about 22. How say 22 billion.
124 triệu này, 124 tỷ.
Yes. It's about like that. It's a lot. Is that okay? 5.4. Yeah, that's about like that. That is large amount. Is that okay? You understand? You know that the A2, the A2 building of IU.
Yes.
How much is this? You know, 80 billions Vietnamese dong. Okay, so this project is big. Is that okay? It's big. $5.4 million to construct a new plant for a major manufacturer. The construction of the plant needs to be complete within a year. That means within 47 weeks. They want to finish it here. I make a mistake. A penalty of $300,000. A penalty of $300,000 if this company has not completed construction by the deadline 47 weeks. You know, if you cannot finish it, that means you make it in 48, 49 or something like this, you have to pay this amount of penalty. Okay, to provide additional incentive for speeding the construction, a bonus $150,000 will be paid if the company to the company if the plan is completed within 40 weeks. So that means that if you reduce 7 weeks, is that okay? If you can reduce the completion in 7 weeks, you can get $150,000. $150,000. So that is the condition. Is that okay? And now, have decided to focus in initial planning on meeting the deadline. Well, first of all, we think of the we have to calculate the way of how to realize it and to meet the deadline. Is that okay? We postpone, think of having a bonus, $150,000, but we think first of all, I'll finish it in 7 weeks. We try to finish, how to control, to manage the project within 47 weeks. Is that okay? And that's cost $5.4 million. Is that okay? And the construction manager is David Purdy. So we are talking about him, just only him. Is the head of the project. We call the construction manager. He managed everything. He tried to control to build the plant so that the project will complete in 47 weeks, 1 year. Okay, then how can we do this? The preparing phase. That first of all, in order to form a project, first of all, you have to spend time for the what we call here preparing phase. Preparing phase means what? What are the works that Mr. Perty for bringing the project on a schedule to meet the deadline for 7 weeks? That what he have to do first. First of all, he have to determine the main construction activity. Main construction activity like what? Preparing the piece of land. Okay, so remove everything there that's to make the land is clean or something, and to plan to make the base. Is that okay? Build the wall, build the ceiling or something like this. They set up the line for electricity, for water or something. Activity. How many activity? Activity A, B, C, D or something. Is that okay? Activity. Like this. The second one, arrange a number of crew to perform the construction activity at different time. Arrange a number of crew to perform the construction activity. For example, they have to arrange, because the worker who build the wall cannot make the concrete for the base, so they have to form the group for make the base, group for build the wall, group for making the electricity or something. Okay, so number of crew to perform a construction activity. Each of activity here need special crew, special group. Okay, determine order of the activity. They have 20 activities: A, B, C, D, E, F, G, H, K, L, M, N, or something like this. So we have to arrange the order, which is before another one, which before. Okay, and then determine the order activity, which activity that must complete. We call intermediate professor, no later than the starting time of the given activity. For example, if you want to build the wall, then first of all, the base must be finished. But sometimes it's not necessarily finished. It should be finished in 3 days or something like this. Then you can build a wall. That's the things. Concerned each of crew supervisor to develop an estimate of how long the activity should take when it is done in a normal way. Now we have to suppose, as I tell you, if it is rain, it is storm or something, then we postpone to say about this. But we first say in the normal condition. In a normal condition, if you want to build a building like the A2 of IU, is that okay? And the first wall, the wall of the first floor, was big like this, and how much time for it? And during the building the wall, we can build some make some concrete of some pillar or something like this. So each of this, you need the crew supervisor to develop an estimation of how long this activity will last, something like this. And how long the activity, we should make the activity done in the normal way, normal condition. Okay, so After doing that, then you will have you will have a table like this. They will make after working with some experts. They arrange which one is first. For example, first of all, you will do A, and after A, then B. Is that okay? After B, then C. After C, then you can do D, and then you can do E. Is that okay? But after E, then you can do F or something like this. So it's all things here. Okay, and each activity, the expert tell you, for example, you do the exterior painting in 9 weeks in normal condition. Install the flooring, it takes 4 weeks. And after J is finished, after the activity J here is finished, you can do K, but K will take you 4 weeks, for example. So everything is here. But if you sum up these things, and then 79 weeks. 6 you sum up with this one, 79. You see, but the time for us, is 47 weeks. Is that okay? But don't worry, because many things here. If you take a look at here, and then you see, okay, my God, the total time here is 79 weeks, but we have to finish in 47. Then it's quite hard. Okay, so it's impossible. But no, not like this. We need to. This table is not the good way for us to describe the project. And it's impossible to look at here to calculate the time of the project. No. So that's the reason why we need the method. PERT, CPM. The method is this. Here. How to do. So a section here, the section in the book, section in the file. In the file I send you, the file in the book of Hidie and Lieberman, the book of Hidie and Lieberman. That is the book. Let me show you. Here I see CPM Lieberman here, the last one. Here. That is in the book. Here. And Lieberman, maybe like this. Yeah, book of these two authors. And I also give you something here. This is CPM, and this is the book of Taha. Book. The book name is Operations Research. Of Taha. Yeah, this book. I write down here. So CPM here. But in this book, they make things in there are 2 ways, and the 2 books, Hilly Lieberman and Taha, make things in 2 ways, different way. And I follow the way of Lieberman, and this way maybe we should make a seminar or something like this. Let me think of this, and after the midterm test we will talk about this. And there is another things. there is another chapter here. Is is a chapter 15 of another book. Is that okay? And also here, so I give you all so that you can here. Let me check. Okay, let's. Okay, that's so I give you the three. Here is the three chapter of three books, all written on the CPM and PERT. So you can compare, you can read, compare. But this one is this book is a textbook. Textbook. That means the main book we use. Okay, this one. That is chapter 10. And here, chapter 10 and section 10.2, section 10.3, 10.3, section 10.3, section 10.3, section 10.3, something like this here. Give all the information in table 1. Mr. Perry now wants to develop answer to the following question. In order to realize the project, he needs to raise up some question like this. How can the project be displayed graphically to better visualize the flow of the activity? He realized that if you put the project, if you let the project in this form, so it's quite hard to realize things and to follow, and so we need another way. That okay, some way to make it in the graph, the how you say, the graph or the network or something like this, to see it easily. The second question, what is the total time required to complete the project with no delay occur? If everything is normal, in normal condition, no delay, and then in order to work, to complete the project, how much time? You understand? How much time do you have to work? Do you have to, how much time needed? You understand? For example, you see here. For example, from D here, after D, you can do E. You know, after D, you can, after the activity D finish, you can start to work with E, but you also can start to finish to work with F. You understand? You can work for E and you can work for F. Both can start after D, but this one needs 7 weeks. This one needs 5 weeks. And so maybe F finish first and E finish 2 weeks later. But you have G. The activity G only can start if you finish both of this. You see? You understand? After D, you can start both the same time, E and F. But E needs 7 weeks, F needs 5 weeks. But after you finish both E and F, then you can start G. You know? Then how many weeks you can start G from D? Is it 12 weeks? No, certainly not. Very easy. F finish first, 2 weeks first E. Then F finish, we have to wait 2 more weeks to finish the E. And after finish E, that means just after 7 weeks, we can start G, you know. And so the calculation in the table there, 7 plus 5 is 12. So that means you think that after finish D, 12 weeks, then we can start G. Not correct, not correct. And so to distinguish, to describe things here in the network like this or in the charts may be better to understand things. Hello, you understand? Hello?
Yes, yes.
Trần Lê An Thắng, you understand Thắng? Thắng, you are sleeping? You are there? Yeah? I don't know. Couldn't understand. I will try it. I don't know. Try means what? I'm talking and you understand what I'm saying or not? You say you try means what? Hey. Thanh Trúc. Hello, Thanh Trúc.
Yes, yes.
You understand what I'm saying here?
Yes, teacher.
Okay, thank you. I think that if you don't sleep in, then you understand. Everything is very easy. So the third question is, when do we individual activity, the individual activity need to start and finish at the latest to meet the project completion? To meet the project completion. For example, if you look at this table, so age, look at this one. So you look at each, you have to find out like this. Then in order to control the project, you need to think of this. This one, when this is start, when it started, when we start age, so that we do not make the project longer than the deadline. You know, for example, if you calculate this, then if at each of the activity you calculate, you have a number like this. This should be age must be start at the week 20 to the week 22. Latest is 22. The activity H can be start at the week 20 and the latest is week 22. If at the week 22 you have not yet start H, that means you will be late. You understand? You have to calculate that. The latest possible that one activity can start. If you start this at the week 24, then I know that your project will be 2 weeks late, certainly. If you don't do anything else, if you don't speed up by reduce something else, then the project will be late 2 weeks, certainly. So the number like this, you need to calculate. Okay? You need to calculate. You need to know each activity start at what time and finish at what time. Is that okay? There are many ways to do, but one way is we do like this, and another way is we do like in this thing. We can do in the network like this, but the one way which is here Gantt chart. The Gantt chart is here, and the time actually the one I use here is the Gantt chart. I used 2001. In 2001, I used it to manage the project of building my house. You see, for example, the activity E. So here, the activity E must start at the week 15, and it will last for 5 weeks here, 5 weeks. But at the week 15 here, you can start at the same time D and E, D and I. Is that okay? You can start D and I, and here, and when the D finish, you can start the G. Is that okay? And when this finish, you can start at the same time the 3 E, D and I. When E finish, you can start F. See? So everything is this. And you know, for example, F must start at the week 20. If you start the F later than 20 weeks, then the project will be late. Certainly. So you see, we look at this one and then we can control. And you know that, for example, by some reason, for example, this you know, for example, this one, the G finish at the 20 weeks here, and then you start this one. Is that okay? And then you start this one. But if here is late, 22, and then this will be late here. And this late, that means that this one will be late, and this one also be late. You see? And then it will be like this. And that means the project will be some weeks late. Is that okay? For example, if you can think this is just about management. There is no mathematics. It's okay. We use some idea of mathematics to calculate, but see here, for example, if this one, you know, this one is late, some week late, then how do? You have to reduce, find a way to reduce, to ask the worker work at night. You work the last thing from 6 o'clock to 9 o'clock, 3 hours more in the evening or something, and they pay them more or something. You have to pay some more money to reduce the time. Okay, and by this way you control this one. But the problem is how to calculate to get the time here is there is a method. Okay, not easy. Okay, maybe we have 10 minutes for the break. Okay, 14:46. So we say 14:47. This 14:57. Okay, so 15. Okay, type a break at 15 to 15. Okay, then we continue.
Dạ thầy ơi.
Yes.
Giờ em có thể xin vào lại được nhóm không thầy? Tại hồi nãy đầu giờ mạng của em bị rớt đó thầy, ngay cái lúc mà thầy hỏi.
You Khánh Linh.
Dạ.
But another one come in. This is have 5 students already. So you want to come in? So group will be 6. That you want?
Yes.
Okay, let's come back and then remind me when we come back to the class, and I ask somebody else. Okay, that's okay. Tell me when we come back to the class again. Okay.
Dạ em cảm ơn thầy.
today. Just okay. Two things I want to. Hello, you hear me? Hello.
Yes, we can hear you.
Two things I would like to tell you is the first one is remind you that next week is the midterm test, and the midterm test we realize at IU, you know, it is direct. You come to IU and the room of the exam, you know, it's 507 or 82507. Is that right? You have to check. Is that okay? This. Calculus 2, optimization 1, optimization 2, decision making 8. You are here. Let me write down here. The midterm test, decision making 08 April 13 and 2 hours to 100 minutes, and the room is 82507. You remember? Your exam was here, not online. Okay, that's the first thing. Another thing is about the oh my God, where is it? Assignment here. In the assignment here, Miss Khanh Linh, she said that at that time she wanted to join in the class, but at that time she was out of the network, so of the internet, so she cannot answer me. So I think that okay, if she still like to come to work with you, you should agree. Is that okay? So our group have 6 students. Is that okay? The other members you see, Huệ Dung, Minh Thư, Thanh An, Đăng Khoa, Tuấn Anh, and Khánh Linh. Okay. So we're gonna you come together, try to come together and work together. It's okay, no problem. And remember, 6 students here write only one report. One we call it a report. A report means like an assignment, like other people. Is that okay? Other people do an assignment, means like a report here. You do like the 6 of you, just one, and write down the name of your group. And then you also have something we call slide file. Is that okay? And with the slide file, you make a presentation. You make presentation at class. Is that okay? And send me to this. Okay, that's all. You have any question on the midterm test?
Thầy ơi, cái bài present này thầy có thể up cái đề chi tiết lên Blackboard giùm tụi con được không thầy?
Cái đề assignment là cái chương 2 đó. That's
Dạ,
the chapter 2.
ý
Oh,
là con sợ thi xong rồi quên cái yêu cầu của đề á, nên là thầy up lên Blackboard cho tụi con có gì thi xong rồi tụi con vô tụi con coi rồi tụi con làm luôn ý thầy.
you mean this page or what?
Dạ. Cái yêu cầu của cái presentation á, với lại
You have a chapter. You have a chapter. Listen. Chapter 2 here. Look. Chapter 4. Chapter 4. Oh my God, where is it? Chapter 4, we have there is, where is it? Here. Here you see, you have a chapter 2 here. Is that okay? You make presentation, all of this, but it's very easy. You take a look here. You see the basic definition theory. You make the definition and something like this, and with the notation like this one, expectation, and you have the minimax and maximin strategy, then how to find it. See here, saddle bonds, the definition of saddle bonds, and you have two things: 2 multiplied by n games and m multiplied by 2 games. Okay, so this n by 2 games, as here it's the same like you see. You have the minimum, you take the minimum and choosing the maximum here. Is that okay? And it's almost the same as before. And here is the maximum. You have something here, you take the max. Is that okay? The maximum of the line there is this, and the minimum. Yeah, okay. And strict in the case that you have some matrix like this. Is that okay? It's not 2 by n, it's not n by 2, but 3 by 3. Then how do you do? Try to reduce it into 2 by 3 or introduce it 3 by 2 or something like that. You reduce at least one of the two sides. The player have a only two, and maybe you see it's long, and here, and the example. I think the example you should take some example here to okay, if it's hard, then I don't know if you see that the content of the chapter is long. If it's long, then I can make one more group, so 2 group sharing this this content. Both of them can make this, but maybe in when you make presentation, one group make one part, something like this. You like to have 2 group? Some other there are other people want to form another group to make presentation. Any of you want to form another group? Hello? Nobody like? Okay, so it's okay, no problem. But you Okay, this one group is okay, 6 students. It's a bit long, but no problem. Okay, so we continue chapter 5. You have any I don't know if I tell you already. Because it is a direct work at the IU, and it is so it's not the the open exam. You cannot print a lot of books or something like this. You need one sheet here. You are given one sheet double-sided. You see, one sheet like this. You can write down here and here, double-sided. You bring with you only this, you know, and you don't need to print wrap paper or something. No, the wrap paper you have it. The university will supply you the paper for writing solution, the wrap paper, A4 like this. But for the reference, you use only one reference paper. You can print some formula, minimax, maximin or something. Write formula this in the 2 sides of a paper. And you write down your name, full name, the student ID in this paper. You see? In the class of exam, if you don't have your name here, they will take it away. Yeah, okay. The proctor will take it. So you have to write down full name, ID, and then you write down any formula you like in both sides of this. Is that okay? You have any questions? Hello? Hello? No?
No, sir.
Okay, thank you. So the duration is it's from 90 to 100 minutes. Okay, you work, and in this case, maybe no multi choice, just only writing question. You may have 5 questions, each question 20 marks, or you may have 10 questions, each question is 10 marks or something like this. Or 4 questions, each question is 25 marks. Anyway, no problem. So look at the chapter 5. Here we continue. So the problem is you have this and a lot of questions raised up, and I'm talking about the question 3, the question 4. When can the individual activity start and finish at the earliest if no delay? For example, we look at the activity of install the electricity wire in the wall. So when it will finish, when it will start, the earliest that you can do, time is relaxed, and then you can do it. But what is the earliest time for working? What is the latest time for working? Or something like this. Which of the critical bottleneck activity where any delays must be avoided to prevent delay project completion? This is a very important question, the question number 5. Which of the critical bottleneck activity? You know bottleneck, what does it mean? Bottleneck. You have a bottle, like a bottle of wine like this. You have a bottle like a bottle of wine like this. And then, yeah, the bottle of wine here. And this is a bottleneck. Is that okay? This is a bottleneck. Okay. And now people often call the bottleneck activity means the activity that is very narrow. You see, here is large. But if the water here were to come out, it must go through this one, and this is a very narrow thing. And sometimes people use a bottleneck in many. For example, a bottleneck place in the street. For example, the street may be like this, and then that's this. Yeah, that is the bottleneck one. Is that okay? This area. So it's very narrow. So in the project, you have something, you have some activity, but are there any bottleneck activity? And that must be, for example, there are some bottleneck like there is an activity. If you say activity like a J, activity J is a bottleneck one. That means it must start at the 9 week, the week number 9. Exactly. Cannot be sooner. Cannot be sooner because everything here then finished at the 9. But it must be start exactly at the 9th number, the week number 9, not later than. If you start at the week number 10, then that means that the completion of the whole project will be late 1 week. That is called the bottleneck activity. And one of the question is we find out which bottleneck activity. We find out that, and when we pay attention, special attention on this to keep it on time, you know. Just wait a minute. Okay, sorry. So a lot of questions. So we count all the questions, all the problem that Mr. Puri, the program manager, have to think first, and then find a way to find all the answer for this, and in order to keep the project in time. Say 5. And the number 6, find the other activities, how much delay can be tolerated without delaying the project completion. Some of the note, that means some of the activity, for example, the activity H, it can be start at the week number 5. But if you delay it into week 7, then the duration, during the 2 weeks like this, from week number 5 to week number 7, if you start at 5, it's okay. You start at 6, okay. But you start at 7, it's still okay. You know, there is some of the activities have some how you say some relaxed time. Is that okay? And we find out all of this, all of the notes, all of the activities, and have some relaxed time like this. And we have to find out exactly at each of the such a notes how many weeks can be delayed. You know, that means in this activity things can be delayed a bit, but we need to find out at each of this kind of notes, how much time, how many weeks can be delayed at the maximum. More than this, then it's late, you know. More than this, then the completion time of the project will be affected. I think the question number 6, we still have some more. Question number 7, given the uncertainties in accurately estimating activity duration, what is the probability of complete the project in the deadline? That means that in case here are the question, very hard question, and you need calculation. You need mathematics to calculate. You need estimation. You need probability. Here you see. What is the probability of completion the project by the deadline? If there is some of the thing happen and some of the activities delay or something like this. So what is the probability? For example, in case he want to reduce it to 40 weeks, okay, he want to reduce to 40 weeks to get the bonus, $150,000 or something. So he can reduce it 7 weeks, okay, and he pay $50,000. He pay $50,000 to reduce 7 weeks. That is okay. That is okay. That he still have $100,000. So that is a lot of money. But the probability of for the successful for the success of that process is just only 60%. You know, you need 60% of the chance. 40 weeks, then you get $150,000, and you pay $50,000, so you get the pure interest is 100,000. But the probability of successful is just 60%. That is a bit dangerous. Is that okay? If it is delayed, it's come to 41 weeks. 41 weeks, then you don't have $150,000. So you lose $50,000. You see? So in many cases, so in that case, a lot of calculation. The probability theory should be needed or something. That is part 2 of this chapter. 8, extra money spent to expedite the project. What is the least expensive way to attempt to meet the target completion for a week? That means you want to get the $150,000. How many money you will put here? Is that okay to speed up or something? How should ongoing cost be mentioned to try to keep the project within the budget? Okay, should go on ongoing costs be monitored to try to keep. Okay, so this equation, the question here, the question from 7, 8, 9 are the next part of this chapter. And with the slides here, I finished the first part, and to the question we will answer to the question 6. That okay in the first part. Okay, and we study mainly in the chapter the 2 parts. The part 1 is here, analyze data. So including here, that's question 1 to question 6, and part 2 dealing with the uncertainty estimation or something like this, and the question 7, 8, 9. That okay? And our the lecture notes I give you just for the first part. The second part, okay, I will upload to the Blackboard the next week. the week after the midterm test, before. Okay, and so how can we do that? How can we realize things to manage the project? Then we use a network to display the project. The idea is this. As analysis of reliable company project show to describe the project, 3 types of information are needed. 3 times of information are needed. The first, activity information, determine the individual activity of the project up to some desired level of detail. That is the activity of the information on the activity. Determine the individual activity of the project. The second one is a procedure precedence relationship. What is we call immediate predecessor and the successor. That here, the activity here, activity H. So what is exactly right before and right follow here? That okay? Right before, right after. The right before we call predecessor, immediate predecessor, and the next one we call successor. They're not here, but and the time information, estimation the duration of each activity. As I tell you that the Mr. Perry have to collect some experts, some group of experts for each of activity to have an estimation that in the normal condition, how long the activity will take, something like this, and for each. And there is several ways. And the thing we have is the network. We have to propose a way how to display the project here in the network. And there are several ways. Project networks here. A network used to represent a project. So the network need to convey, that to transfer all the mentioned information in a visual way. The network so that they can display all the things that you have before. The duration of the activity, what is immediate predecessor, what is immediate successor. Yeah, okay. What is right before, right after. Okay. So we shall use the activity on node, AON. We shall use the activity on node project network. That means we use it, and in the book, in the textbook. The way in the textbook of Hillier Lieberman. And there is another way, some other ways in this is AON, you know, this is AON. There is another way in the book of Taha. In Taha, it's not like this, it's another way. But we just focus on this way. Activity on node. So that means that we write down here is B. So that means that is activity B. Activity B and running on node here. And the number here is the duration. The activity B will last for 4 weeks. And here is the predecessor, right before. And here is successor, right after. You know, just like this. Okay? And by this way, you will come back to the question 1 is what is the total time needed to complete the project if no delay occur, but we will leave it for the next week. No, the week after next week. No. The the time is next week is the midterm test. Is that okay? The week after next week is a presentation. And the week after is we continue here. But so we come back to the way we do like this. Then how can we make the project there in the way of the network here. For example, we have this. Is that okay? We have this. Then how can we work? First of all, you have A. Is that okay? And after A, you have B. After A. Is that okay? C after B. Is that okay? And then we have this. Let me. I have to. Okay. I want to use the rough paper. Is that okay? And you remember I make a photo of this, and then I will tell you. Rough papers. No rough papers here. I remember. Okay, rough paper here. So at the beginning, you have what? Normally at the beginning, you have A. You have to A. You have A. Is it okay? And after A, you have B, like this. And after B, you have C. And A take how many time? A excavate 2 weeks. 2 weeks. B 4 weeks. And C 10 weeks. 10 weeks. Is that okay? And at the beginning, we often do like this. We write down start. Here. Start, and then this. Is that okay? And after C, you will see what? C, you have E. C, just a moment. D, E, after C. D, both D and E after C. So you have here D. You have here E. Both of this after C. So that means after C, you can work with D and E. You can work with D and E. And D 6 weeks and E 4 weeks. D 6 weeks and E 4 weeks. You have this. Okay. The predecessor of both D and E are C. And the successor of C is D and E. Okay. And then what's next? G. G is after D, 7 weeks. G is after here, G. G after D and 7 weeks. And H after E and G. H, you know, after E and G here is H. You see? After E and G is H and 9 weeks. 9 weeks. Is that okay? And continue this way, and then you have seen A and G, and you have I. I is just after C. I is just after C. I is here. I is after C and 7 weeks. So here is 7 weeks. And then you have J. J after F and I. F. Where is F? Oh my God. Where is F? F is after E and 5 weeks. F is after E here. F after E and 5 weeks. Here is 5 weeks. And then after F and I is J. J is here. After F and I, like this. And 8 weeks. 8 weeks. Is that okay? And then KL, both after J. KL, both after J. This is K. This is L, both after J. And K 4 weeks, L 5 weeks. K 4 weeks, L 5 weeks. And then M after H. M after H and 2 weeks here. And then the last one is N after KL. That's N. After K, after N, KL, and after KL, 6 weeks. You see? So you can imagine you have some figure like this. Oh my God. Yeah. So you have some like this. Is that okay? What is the end? The end may be here. The end may be after all people write down like this. End. After all people write down here the end. I'll finish. That's after you finish this one, you go to an end. Is that okay? And now if you look at this, oh my God, terrible. Here you see, from the start, and you have here, and at least you look at this, and then you will see that, at least you look at this, and then you will see that everything is quite clear. And now I ask you the last question of our class today. Who can calculate for me, in order to finish this project, how many weeks in total to finish here? So now from here, then up to you. Sorry, it's a bit here, there, that's like this. You see, I make it smaller than, okay. So who can tell me how many weeks is needed to finish at least this? We can finish this in how many weeks? Can you calculate? Hello?
Maybe 40 weeks, teacher.
Your name? 40. So, who? You are what? You are.
Em Huệ Dung.
Okay, Huệ Dung. 40. Some others?
Em nghĩ là 44, I think 44.
Who?
Khải.
44. Some more? Huệ Dung, you remember that if it's 40, then certainly get $150,000. Because the bonus, if you finish in 40 weeks, you get a bonus, $150,000. Somebody else? Can you see? Can you calculate how long for the project? Listen, like this. Maybe because the time is finished. I don't know if any of you have another class, but you do like this. We make a line from A. Oh my God, what is it? Look, a line from A to B, B to C. That is nothing else. But you have something like this. You have a line to finish. You have this line. You have this line. You may have. Oh my God. You may have this line, and this to finish. Is that okay? That is one path to the finish. How many weeks? 6, 4, 10. You have one path, and now you have another. You may have another path like this. You may have another path like this. A to B, B to C, C to D, D to this to H, H to M, and M to N. M to finish. And you have one path. Is that okay? This I call the path number 1. This is the path number 2. The path number 1, the path number 2. How much? How many weeks? How many weeks can you calculate? For example, the second path 2 now is 11. 11, but 11, 14, 20, 20, but 10 is 30, 34, 36. So the second path is 36. The second path is 36. And this one, 4, 10, 18, 23 with 4 is 27, 27, 30, 27, 37, 30, 41, 43. It is 43. Is that okay? But you also can have something. For example, you follow the route 2, the route 1, but you go this way, and this way, and this is the route number 3. So you have the path number 3. It should be 44. Is that okay? And the longest way, the longest path from the start to the finish here is the time to finish, and it should be 44. And that means that Khải is correct. So I give Khải 5 points. You understand? There are many ways from the start to finish. You can go many ways like this. But the longest way is the way that's longest way. The duration of the longest way is the total time to finish to complete the project. Think of it. That's true. Is that okay? We will explain about this when we come back here. Okay. And remember two things. Next week, you have no class, but you have a midterm test. Is that okay? Midterm test is direct at IU and at the room 50. I remember 504, 504 or something like that. I write down there already. Is that okay? At that time, and you need to bring with you only one sheet of reference paper like this. With the double side, you can write down anything and nothing else with only the pen. Okay, of course, the calculator if you like. We need to have the calculator in case. Okay, it's nothing special. We don't need to use the table of normal distribution. No, you just use the what you say, Bayes theorem. That's all. Okay. With the decision making under uncertainty, you under risk, you need to calculate a bit about the probability. Okay. Bye bye.
I have a question, sir.
Yes. You are Cẩm Thanh. Okay. You have
yes.
question what?
When will we have the presentation?
Presentation is exactly at the class the week after the midterm.
So we have the 2 week of midterms. So it's the
only 1 week, not 2 weeks. The midterm is 1 week or 2 weeks?
2 weeks.
Oh my God. Let me just a moment. Very sorry. I have to. The midterm start at the 4/4. What? Oh, no. The midterm started at the week with the April 4 until 6 until 7, 8, 12. Oh my God. 12, 13, 14. So you have any exam on the second week from 11 to 16?
yes.
Sure, teacher.
Yes, teacher.
That is so that means that the midterm test you realize in 2 weeks. That's unusual. We never have this. The final exam is 2 weeks, but the midterm tests. Okay, so let's say I will ask the Department of Mathematics, and I will write an announcement in the blackboard. Is that okay? In case you have 2 weeks of midterm test, so you have 2 weeks free from the lecture, and the week you start the class again will be the presentation. Okay.
Okay.
The week of studying, the first week after the midterm is the week for the presentation. You make presentation, okay? That is okay, but there is one. So it's okay. There is one student is Hảo Yên. It's okay. Hảo Yên. Okay, bye bye. So you can leave except Hảo Yên. I need to ask you a bit one question. So bye bye. We can. I will leave.
Yes, goodbye. Thank you very much.
Bye you. So bye. I'm leaving, but you can leave because I need to talk to Hảo Uyên a bit. Hảo Uyên, you are there? Hello.